Ever notice that almost every massive cargo ship or oil tanker has a bright red bottom? That's not a design choice. It serves a very important purpose. The vivid red color creates a strong visual contrast against the dark ocean water. And right where those two colors meet is something called the waterline. Just above it, ships carry a special marking known as the Plimsoll Line. This symbol shows the maximum safe loading depth of the vessel. Crew members and dock workers only need a quick glance at that contrast. If the water covers the reference mark, the ship is overloaded. And leaving port in that condition could mean disaster in the very first storm. In other words, that red paint acts as a giant warning backdrop for one of the most important safety indicators on the ship. But below that line, an entirely different battle is taking place. A non-stop biological war. Back in the age of wooden sailing ships, vessels weren't destroyed only by cannon fire. Sometimes their worst enemies were tiny creatures living in the ocean. The moment a ship entered the water, it became an artificial reef. Millions of barnacle larvae attached themselves to the hull and formed thick layers of hard calcium shells. Those heavy buildups completely ruined the ship's hydrodynamics. Speed could be cut in half. Maneuverability dropped dramatically. Then came an even more dangerous attacker, shipworms. Despite their name, they aren't worms at all. They're wood-boring mollusks called teredos. These creatures tunneled through protective tar coatings and carved long networks of passages inside the oak planks. From the outside, the wood looked perfectly fine, but within months, it had been hollowed out from the inside and turned into something as fragile as a sponge. The timber rotted. Leaks appeared far from shore. Sailors had no choice but to haul their ships onto land every few months. Crews spent countless hours scraping away tons of marine growth and replacing damaged structural components. The breakthrough came in the second half of the 18th century. Engineers working for the British Admiralty tried something revolutionary. They covered the underwater section of an experimental frigate with thin sheets of copper. The results were remarkable. Copper acted like active chemical armor. When exposed to seawater, it slowly oxidized, continuously releasing toxic copper ions. An invisible, poisonous halo formed around the hull. Barnacle larvae died before they could attach themselves. Shipworms couldn't penetrate the hard metal barrier. Suddenly, the British fleet gained a major strategic advantage. Warships could patrol the world's oceans for years without losing speed or maneuverability. Constant shore maintenance became unnecessary. Copper sheathing quickly became the gold standard of shipbuilding for the next century. Then the Industrial Revolution changed everything. Wooden ships gave way to iron and steel. Shipbuilders initially tried attaching copper sheets directly onto these new metal hulls. And that's when a serious problem appeared. Seawater turned out to be the perfect electrolyte. Essentially, the ocean created a giant battery. A powerful galvanic reaction formed between the copper and the iron. In this invisible electrical circuit, the iron became the sacrificial metal. It continuously gave up electrons to the more noble copper. The result was aggressive electrochemical corrosion. Steel rivets and hull plates literally began dissolving underwater. Hull structures weakened within months. Strong metal transformed into flaky rust. The same material that once protected ships was now destroying them faster than any barnacle or shipworm ever could. The industry needed an entirely new solution. The answer was simple but brilliant. Instead of attaching solid copper sheets to the hull, engineers isolated the copper from the steel. Chemists developed a special anti-fouling coating by mixing active compounds into a thick paint base. Its key ingredient was copper oxide. This paint worked as a reliable, insulating barrier. The dangerous galvanic circuit was broken. Electric current could no longer attack the steel hull. At the same time, microscopic copper particles continued slowly leaching into the water. The protective chemical halo remained fully intact. And that formula permanently shaped the appearance of the global shipping fleet. Copper oxide naturally has a deep brick red color. Manufacturers didn't need to add extra pigments. The distinctive shade appeared automatically during production. A practical compromise between physics and biology gave ships their iconic look. Today, modern chemistry can create protective coatings in virtually any color imaginable. Active biocides can easily be mixed into blue, black, green, or almost any other paint. Yet ship owners still purchase millions of gallons of traditional red coating every year. Why? Because the maritime industry is famously conservative. Over 2 centuries, that brick red color evolved into a global standard. Port authorities, inspectors, and dock workers around the world instantly recognize it. Subconsciously, that specific shade signals that the hull has been properly protected. What started as an accidental side effect of 19th century technology became an unbreakable maritime tradition. Today, a red ship bottom isn't a chemical necessity, it's the vessel's passport to the ocean. If you enjoyed this, smash that subscribe button, and I'll see you in the next one.